So next is Ginger Grant, and she's going to be discussing data-driven decision-making with Azure Machine Learning. Ginger is the principal data geek at Desert Isle Group. She's a data platform MVP, and she provides consulting services and advanced analytical solutions, including machine learning, data warehousing, and Power BI. She's the author of multiple articles, books, and she blogs consistently at desertislesequel.com. And she provides data platform training as well in Python, R, and Azure Machine Learning. So she's a dynamic speaker and a regular at conferences and user groups, and we're definitely glad to have her tonight. So with that, Ginger, take it away.
Thank you very much. One thing that I wanted to do is this is going to be kind of a follow-up to one of the sessions that was where they were talking earlier about AutoML, because that's part of Azure ML, which we are definitely going to be investigating and taking a look at what you can do with it and how you can use it and use it to incorporate machine learning in a lot of solutions. Contrary to what you may have heard earlier, you do have the ability to not only take a look at what exact algorithm is being run, what hyperparameters are set, as well as determining how long you want to look for the best algorithm possible, and then how you can implement the solutions. We'll take a look at all that good stuff. All right, so I won't bore you with the second intro. One thing I wanted to mention is I'm also in addition to being a data platform MVP, I'm also a Microsoft certified trainer. And in August, I was part of a group of MVPs that wrote a book on beginning cognitive services, which is really pretty cool. Really enjoyed doing that. All right, so what I'm going to talk about today is what Azure Machine Learning does, what you can do with it, how you can bring your own code and incorporate that in Azure ML. I'll talk about AutoML and the different ways that you could implement that, both in a low, no-code sort of fashion. And then I'm going to show you how to write AutoML using Python. I do more with Python than .NET, so I will pull up the Azure Synapse environment and show you another way of implementing AutoML. Then we'll take a look at different ways of testing and deploying your machine learning solutions. All right, so Azure ML at the 1,000-foot level, Microsoft created this to design an environment where you could track what was going on. Not only people write a lot of ML, and then it kind of gets lost in the sauce as far as, you know, how do I test this? What kind of automation tools are being used to determine that the model hasn't changed? A little bit about changing models. One thing that's really fun about doing data science and machine learning is its continual employment because the world changes. For example, at one point in time, I was working at a very large credit card processor, and one of the rules that they had was that if you changed your address to Hollywood, Florida, they would probably put a stop on your credit card and give you a call. Why is that? Well, because there was a large gang of organized criminals that were operating out of Hollywood, Florida. And if you changed your address to that location, chances are your card had been stolen out from under you and somebody was going to use it to do fraudulent charges. Now, I don't think criminals are stupid. And so I am sure that they figured out that, hey, this Hollywood, Florida address is not working for us. And so they moved. So this is kind of a thing that your model would look for in terms of, if I was looking for fraud, that perhaps would change over time. Because when the Hollywood, Florida location got hot, maybe then they moved to Tampa. You never know. So what is important to do whenever you create a machine learning model is to continually test it to make sure that what you train the model to uncover matches in today's environments. I mean, things change all the time with your data and with the problems that cause it, and you know that are part of it. So you need to continually tune your model. And that's another thing that Azure ML does. Now, one thing that's really important when creating models is before tools got really advanced and you had primarily actuaries doing a lot with R, there was a lot of data manipulation that people weren't really aware of, which meant that if somebody would say, yep, model works, I got data, I'm good. But it's really important to register the data so that it's well known, the inputs that are required, as well as where you're going to record the outputs. Because me running a machine learning experiment on a bunch of data that's coming in is worthless if nobody looks at it. So what you want to do is make sure that you register the model. This way, let's say, for example, that my model is taking data that I'm getting from an application or a series of transactions. It's important that the data be registered, so if it changes, somebody will know that you just broke your machine learning model. Like, for example, let's say that I was doing some analysis on water meters in an IoT fashion, looking at whether or not there was some kind of anomaly going on with my water meter. And this actually happened, and something that I was working on, they got a new model water meter. And previously I was getting 13 fields, and next, I was getting 15. Well, that's not the same data as I was expecting, so therefore I have no idea what's going on anymore. So registering your data can ensure that if the data does change, maybe you get a new model, that your data is registered so that that's known, hey, you just broke machine learning with that. And then once you have a model, you're going to want to train it. Of course, you train it initially to teach it what you want to know. And you're going to then pick an algorithm based on that data, evaluate them, and then deploy that particular algorithm using the model that you trained. So that's really what Azure ML does. It also includes some built-in things for periodically testing your model so that you will get the same kind of results that you're expecting, so that you know if you need to retrain your model, which is something that you'll need to do periodically because data changes, people change, so that your models need to change as well, and they need to learn new things, and that's what Azure ML can do. Deployment is supposed to be easy. You shouldn't have to kill yourself doing deployment. As a matter of fact, it writes a lot of the code for you. Let's face it, with containers, Kubernetes, it's not that big of a deal to deploy a model. It's just important that everybody knows where the inputs and outputs are. And so it's pretty easy to get that code generated for you. So, all right, so what are the kind of components that you have within Azure ML? Well, you've got a workspace, and your workspace is where you're going to be doing your coding, or you're going to be uploading your coding because you've created your model somewhere else and you're just using that. Like most of Microsoft Azure's modern tools, you're using a cluster. And a cluster is just basically a computer that you choose. For example, if you are running a one-time machine learning analysis on a bunch of historical data, you might want a massively huge machine because you're in a hurry. And then maybe later on, you don't really care so much, you're doing less data, you might want to scale it down smaller. So your clusters are your compute, which you can scale, and those, of course, are completely independent of your code. You also have the ability to do things within Azure ML Studio, which contains a designer and notebooks. Enough talk, let's take a look at that. And I'm going to also show you a machine learning experiment that I'm going to do with AutoML. Okay, so let me go to Azure. Hopefully this is a good resolution for you to take a look at. And I'm going to take a look at my Azure ML resource. This isn't very complicated to set up. It doesn't really cost you anything to set it up. Of course, you get charged when you use it. So setting up a workspace is relatively simple. Wandering through the UI, you'll be able to figure it out. So I'm going to go ahead and launch the studio, and you can see I've got a number of different things that I could possibly do. I can code with a Python SDK and run some sample experiments. So just standard notebooks here. I have one that I have written here. This is a tutorial that I pulled in. That uses like a download and prepare data, creates a data frame, cleanses data, etc. So this is just a sample notebook that I pulled in just for analysis. So you could do all of your machine learning development within here, running, of course, in Notebook. I also have the ability to use the designer. Now, this designer is something that is kind of a it's a holdover from a previous application called Azure Studio ML. And this is what's commonly known in Microsoft speak as a clicky, clicky, draggy, draggy kind of machine learning development. So with this particular environment, this is really good for you to start understanding the way the process works. It's really meant to be a teaching tool more than something that you're really going to do once you know anything about machine learning. But one thing I like what it does is it shows you how the different elements work. So here you see that what it's doing is it's taking in automobile price data, and it's using this in a global data set. It's selecting some columns, it's cleaning them, it's splitting the data set into test and training. It's doing linear regression and scoring and evaluating the model. So I can go ahead and run this particular one. I need to create a compute to be able to run anything. So if we select anything in our environment, what we would need to do is assign compute to this so that we could run it. So you see here, there's a number of testing data. These data sets here are the ones that I've loaded. There's some sample data sets. And then the ability to enter data manually or import data, feature selection, and then I've got my series of different algorithms here. So I can teach myself machine learning by playing around in this particular environment should I wish to do so. So this is the designer area. So there's my data sets. These could be data sets that I'm going to be using in my machine learning experiments. All of these are ones that I have loaded, showing you that some of them come from a data source that I have within my Azure environment, and one is from a URI. These are the experiments that I have already run. And I can take a look at the way that they all worked. So, and they're the latest run. It names them for me. I certainly didn't name anything busy salt, whatever. But you'll see that I've got some sample ML in here as well. So if I look at this one, for example, I can see that this one was canceled, so I don't have a whole lot here. We'll go back to experiments. See one that's probably not canceled. And this one, I can take a look at my models here and see that I ran a number of different algorithms and analyzed my results based on all of these different elements. And we'll talk more about that. But this is just a sample classification experiment that I ran previously. So this is just in my list of experiments. Pipelines, I can create a machine learning pipeline. I don't happen to have any here that I could use for testing or development. Models, these are models that are ready to deploy to my environment. These are my endpoints that I may have created for machine learning models. I don't happen to have any of those. And this is my compute instance. So when this is my server that I'm running on, and I have made it a standard compute because I'm cheap. You can have as many of these as you want and configure them in any way that you wish to give yourself the amount of compute resources that you want. These do now run, these are Spark, so that they do take about 4 minutes to spin up, and you are charged for the times they are running, and yes, they do turn themselves off. I've got different environments that I could potentially use that are optimized for different elements. These are my different data stores, blob storage accounts that I have accessing here. I can label my data, and I have the ability to add a number of linked services. So let's actually take a look at a auto machine learning run that I can use to have Azure ML select algorithms for me. And I've got a lot of control over this, and I can also use this to write my own, just based on what it's finding here, have this just be a simple way of selecting. I can see exactly what it determined was the best one and go from there. So what I'm going to do is I'm going to create a new automated ML run. And what I'm going to do is I'm going to use this particular data set, which is the first step. Now, this is my data set. It is a sample data set with information that comes from a bank. And I want to know if someone creates a new deposit account, what their criteria is, and so that I can mark it to the people that would be likely to create a new deposit account. And yes, I know the answer. So that way I can look for these criteria and hopefully come up with the same results that I did in this particular data set. So this is my data set name. So I'm going to go ahead and select this. And I'm going to go ahead and say next. Now, my data, as you'll notice here, this is a simple classification. My value that I'm looking for is a simple yes or no, which indicates that this is a binary classification problem. And I'm going to go ahead and create a new experiment. And I'm going to call it binary classification. And the target column is my deposit column here. And this deposit column basically has the answer, yes or no. So I'm going to select my deposit column. And then it's telling me what compute cluster do you want to use. And I'm going to select the one that I already have running. So the next thing that I'm going to do is I'm going to auto pick classification, since it also realizes this is a binary classification. I have options of classification, regression, and time series forecasting. And I have additional configuration settings here. So I could pick, for classification, there's a number of different elements that you could possibly pick. We'll go over some of those here in a little bit. But I've got a bunch of metrics that I could use for how I want my model to be scored. So I'm going to pick AUC weighted, which is area under the curve, and I want the highest value that I could possibly get. The best value ever is a 1, which is kind of like playing golf and only hitting the ball 18 times. Not likely to happen if I'm going to, and that will be a 1. So it'll be less than that. So something less than 1. So I want it to explain it. And if I don't want to use some certain set of algorithms because I know that's a worthless waste of time, I can do that. So I can say how long do I want this to run? And I generally do 2 things. I'm not made of Azure bucks, so I limit the amount of training time that it runs from generally 6 hours is too rich for my blood, but you could set it to whatever you wish. And for the metric score threshold, I'm going to say that if I hit 0.9, you can stop now because that's perfectly great result. And I'll use that algorithm because it's a really good result. So when my AUC weighted score is 0.9 or greater, then it's gonna be done. So it's not going to run for this hour's length of time. It's going to run for that time. I can have it do different kinds of validation. I'm going to set that to auto. And concurrency, this is how many nodes it's going to use at any given time. So I'm going to go ahead and save this. So again, classification, I have set some additional configuration settings, and I'm going to go ahead and say finish. And this is creating a new run. And we look up here, we see that it is going to be running. I'll refresh it until it does say run. Okay, now that this is running. Now, naturally, I'm doing what I like to call the cooking school version. So you know how they always like show you how to bake a cake and then they like and pull it out and like, and here's the cake. So this is what it looks like when I'm done because I don't want to waste anybody's time waiting for it to come through, although it'll probably do that before the end of this particular presentation. So I'm going to go back and look at the one that I did earlier, which is this dynamic one here. And I did the parameters the same as the one that we just looked at. So this one completed. And again, I'm looking for my data guardrails is basically saying 0.9. So when I hit 0.9, stop. So what it did is it started running until it hit a score of 0.9 and then it stopped. And so the algorithm that it selected was standard scalar wrapper with an XJBoost classifier. And it also shows me here what the data transformation is and what the hyperparameters are, so I know how to code this in the future. So I wouldn't necessarily have to do this clicky draggy version, although I can deploy this as well. But if I wanted to change it up, get a little bit smarter, I could do that too. And I can use the same parameters that were very successful here. I haven't registered anything, I haven't deployed anything, but let's take a look at my configuration settings again. Training time an hour, metric score 09. I do it with auto and it picked the Monte Carlo cross validation. So if we take a look at, and it's using my compute target here. So if we look at the models and the view of the explanation here, we can see that these were the top 5 features by performance. And we can look at the data set. We can look at the individual feature components. So I can see what is, most likely to succeed here. If I look at my standard charts that you might expect that you would see for a binary classification, an AOC is the area under a rock. So a rock is a receiver operator characteristic. So what I'm talking about is I want this area here to be as close to 9 as I can. And so what this is saying here is that it, this is what I got for a result. These were my, the best results was this teal one here. So it's taking a look at the percentage, looking at the different gains. Here you can see the weighted average versus the micro average in the percentile. And we can see that again, I got a UAC of 0.09, my accuracy was 0.824. And this is why it stopped, because I said if I get that good, stop. Now what this meant was that luck of the draw, it didn't have to run very many algorithms until it got this particular result. So it doesn't have to, there are not a large number of runs that were created for this particular run. So there were not a ton of models that were created. It really didn't create a whole bunch of other ones. So there are, generally speaking, it looked at running all of these, but it got to this one and it stopped. So it started a couple of them, but it didn't, they were all in process at the same time, but I got a good result, and so the end of it stopped, which is what it's doing right now. And this particular element that it is running here. So it's going to create a classification model, tell me exactly which is the appropriate parameter, and then I can do this and I can create a model out of this. So when it is done, so I can actually deploy what I created and put this in a deploy this in Kubernetes, and be done. Put this in a cluster and make sure that I've got the different data in this kind of create a pipeline of some kind and run this all the time. So I could run this component, say, from within Azure Data Factory, Azure Synapse, from a web application. I've got a number of ways that I can create a deployable object out of this clicky draggy thing that I just showed you. And yes, it would be, and one thing that's really kind of amazing about this is that because it has the ability to tune your hyperparameters as well as pick the algorithms for you, there's no way a person can be this fast. And as a matter of fact, there are many, many tools that are being used now to select algorithms because machine learning, picking machine algorithms is a more efficient way of doing it. And that is why there are, tens of tools that do the same thing. So Microsoft is, of course, following industry trends. I think you're going to be seeing more and more where the algorithms are going to be picked by library components rather than by individuals, at least if it's something simple, just because it's so much faster and they can be very complete in the different kinds of algorithms and tuning that are involved. So I think that you're going to see this more and more in the next few years. Okay. So for when we're talking about machine learning, there's a bunch of things that are what considered giant time sinks, as in things that waste a ton of time. Believe it or not, you do not spend all of your time, well, the majority of the time that you spend is not determining the best algorithm. It's cleaning your data and formatting your data in a way that the application wants to see it. For example, let's say that you have data that includes text. Let's just say I'm looking at determining when fruits go bad, and I've got apple, orange, and banana in one column called fruits. Well, algorithms don't like that. So I would either want to replace my values of fruits with 1, 2, and 3. I could do something called Hot Encoding, which would do a pivot of my data so that I would have a column that says banana and it would have a 0 if it wasn't a banana or a 1 if it did, and so forth and so on. So that's the kind of data cleaning that I would need to do to reformat my data in a way that can that the algorithm can best use it. So that's a lot of the data cleaning that's going on. In addition, I'm going to have to figure out what I'm going to do with missing data. Most of the time, I can't do anything with missing data. So I generally ignore it, blow it off, get rid of it, because it's not something that I can evaluate because it'll screw up my algorithms. Of course, determining the best algorithms, there's tools for that, or I can spend time doing it myself, which of course I do periodically. And then once you have a decent, once you've got a decent algorithm selected, then you need to tune your hyperparameters to even improve the performance that much better. So maybe you might want to use, figure out the best algorithm yourself, and then use a tool like Automl to pick your hyperparameters, because that's just mindless stuff, and changing those values gets to be really annoying. So it could be something that you do in a combo. So the reason that algorithm selection takes so long is there's so many possible options. And of course, you need to have a lot of data to prevent overfitting. Now, overfitting is the case where the machine knows the answers, and so it stops looking at the questions. For example, if you have ever looked at an exam that you were trying to cram out of, after a while, you just know that the answer to 12 is B, and you stop reading the questions. Well, machine learning works the same way, so you need a lot of data to prevent overfitting. The best story that I ever heard with overfitting, though, was for all of you Lord of the Rings fans, including myself, all of the big battle scenes, that's all CGI. And they didn't actually make the little orcs and little elves go after each other. That was all a computer program. And what they did is they just ran it. And they ran that program so many times to get the orcs and the elves to fight and the humans to fight that, and of course they waited, what's a club going to do? Arrow, blah, blah. And they ran the same data set so much that the orcs dropped their clubs and ran off because they knew they were going to lose. Because that's, they got smart, they got trained, and they're like, and we're all going to die, so we're going to run off. So keep that in mind. You do need a lot of data when you're doing this kind of training so that your machine learning doesn't get biased in favor of a specific data set. So ideally, it would just to take a small percentage of your available data, and then you could run a lot of different data over time. But there's so many different algorithms that you could possibly use for different kinds of machine learning solutions that's why the selection takes such a long time. So of course, once you've got that selected, then you need to tune your hyperparameter. And hyperparameters impact the speed and quality of your machine learning process. They're improving the number of the machine's ability to learn. Like for example, let's say you're doing something like a decision tree. Well, you may specify the depth of the tree. Maybe you specify the number of latent factors in a matrix factorization, the learning rate, the number of hidden layers in deep neural networks, the number of clusters and k-means. There's so many different types of hyperparameters that you could possibly tune. And you can't really learn them. It's just basically they help direct the training. And there's lots of trial and error in hyperparameter tuning. And that's in addition to getting your algorithm right. So with AutoML, what it's going to do is you can design and run with by just giving it your data. Ideally, it will perform best if you do all that data cleansing first. So yeah, you really do need to stick with do your own data cleansing. You want to specify the source and format of your training data. Now, here's a tip too. Since primarily most machine learning is now done in Spark, and these are Spark clusters, you will have improved performance if you choose to use Spark ML, including Spark ML datasets, which means if you're using Python, no pandas, you're going to want to use koalas because they will scale better. And this gets into how well you want your machine learning model to perform, how well that it can operate over a number of different clusters. So you want to configure your compute target, where you're going to put your ending of your data, and then configure your parameters. Like what I showed you is like, I don't want this to run in 6 hours. I'm too cheap for that. Looking at which is the most important measure that you could possibly use for evaluating it, give that an issue. There's some particular machine learning algorithms that you do not want to try. You don't try it, get rid of them. Microsoft does use most of the most common machine learning algorithms for classification, regression, and time series. Not all of them, but generally a very wide number of them, including neural nets, so that you can test them in a number of different ways. So what it's doing is it's creating a number of parallel pipelines, and they try all these, and then once you get that exit criteria or the time frame, you're done. And you can, once it's done, you can take a look at what we did in our model to see how important different features are and to see what the overall values are. Now, I kind of did a rig demo. I'll show you one where I had like 25 or 30 different algorithms that it reviewed, so I could take a look at why the other ones didn't make it and what was so special about the one that did. When you're doing that, a number of times you may see that the difference between the winning one and the not winning one was the hyperparameters, because that can really make that much of a difference in your tuning. So of course, conceptually, you've got your different tuning elements, you've got your training data and your testing data. Ideally, you're still going to need to do that cleaning stuff, going through AutoML, and then you'll get a high quality ML model as a result. So it picks the algorithms and the model. If you want to download it and tweak it more, you can. You can basically take the steps out. You know what it picked, so you could look at how you could further tune it using the algorithm that it has selected. And this helps rapidly build machine learning solutions and improving productivity and getting the results out even faster. So you want to define the settings and train it and choosing the best model. So here's what we did, which is basically classification. This is looking at your area under the rock. These are two different values, seeing how it worked. And you want to analyze it to see how much of this data here, and taking a look at how that works. So what I want to show you now is looking at how we can take and use AutoML, not with clicky draggy stuff, but stuff that actually makes you feel like a real developer. So we're going to be taking a look at doing AutoML within Python. So to do that, I'm a data platform MVP, and I do a lot with Synapse. So I'm doing this from within Synapse. So this is my preferred environment for doing Synapse because this is where my data lives, and I've got my pipelines are also contained within this space. I could also code this from within Azure ML, but to be honest, when I started doing this like a year and a half ago, you couldn't, and now you can. So hey, improvements have been made. So what I am doing here is I have some data sets that tell me from New York, what's the criteria, the people that are going to get a tip or not when they take a taxi. And I'm taking a look at that data, and then I'm analyzing it to determine what criteria will determine whether or not somebody gets a tip. So what I'm going to be doing here is I am reading from my blob data store, which is what this AutoML code does here. And it's going to read that. Now, ideally, by the way, if you are doing a whole lot with Spark, which is the way a lot of data processing is going now, and specifically with machine learning, you're going to want to probably make sure that your data is in a Parquet format because it processes more rapidly in a Spark environment because it knows how to read it faster, and it's a compressed data set. So it also takes less space in your blob storage. So I'm just going to look at one day. And I ran this earlier because look, this takes 14 minutes and I didn't want to waste your time. So what I'm doing is looking at all this data, and I'm loading my data in a data set, and between the 7th and the 8th. So I'm just taking a smaller data set here. So I'm looking at the vendor ID, the passenger count, and of course, the tip amount. So I'm looking at whether or not they get a tip. So what I'm going to do is I'm going to create a smaller set of data. I'm not going to use this entire data set so that I have some more things to test and train on. And I'm going to take the vendor ID, the passenger account, trip distance, the starting longitude, starting latitude, and payment type, fare amount, and the tip amount. And I'm only going to look at these different elements. And I'm going to then, this is my subset of elements, so much smaller set than there because I don't care about some of those things. Looking at, whether the day of the month, the day of the week, seeing how many of these things are different. And then I'm going to split my data into 2 data sets. And I'm going to then, from within Python, I'm going to call Azure ML. So I'm going to call Azure ML. I'm going to use my subscription ID and the name of my resource group and the name of my workspace and the name of my region. Again, this follows the same rules as all Azure things do. You want to make sure you're in the same data center so that you don't incur ridiculous charges. So what I'm then doing is I am going to create an Azure ML model data set, and with my testing data here. And then I'm going to do my settings. So the settings that I did in the visual version, I'm doing something like that here. So this one I'm only going to run for 30 minutes. I'm going to say, yes, you can go ahead and enable early stopping. And this time my primary metric is the R2 score. So I'm looking at regression analysis to see what the important elements here. So here we see that I'm doing regression. And I'm looking, so it's going to give me a debug log. It's going to have, there's my training data. It's going to be using Spark, and it's going to take a look at my fare amount and see what my elements are that get my fare amount for me. So here, what it's doing is it is submitting my Spark run here, and it's looking at my different models. Now, I told it 30 minutes, and I wanted the best R2 score here. And so what it did is it did a whole bunch of different models here. So I can take a look at and it, evaluated all of these. And I can take a look at this particular model in Azure ML. So if we look in Azure ML, and I look at all of my experiments and refresh this. And I'm looking at my regression analysis here. We can see all of my runs here and all of the models that it ran. So this is the one that won. Notice it has the highest R2 score. And I can take a look at this, or I can take a look at some of these losers down here too. And so this is showing me the hyperparameters. This is a loser. This isn't the winner. Which one that it used. But I've got, any kind of details, but I've got a lot of other options that I ran in 30 minutes before I got the one that won. So this is showing me all of the ones that it tried. And then it just basically said, oh, we're done. So I'm going to get the best run, and I'm going to test the accuracy. It's calculating the root mean square error here just to see some additional elements on it. I can calculate my model accuracy in my MAPE, and then calculate the R2 score. Do a little plotting here, see how good I was at analyzing this. And then I can create a model that I can just go do and deploy. So here's another way of using AutoML to provide features that I coded for versus I did clicky draggy on. And I've got a number of different results, and I can take a look and deploy my machine learning model that I created here. And I used Python to do it. And again, the libraries that are important to remember that I used here is, well, I use Spark, but this is the Azure ML, and specifying that I'm calling Azure ML from here, and then setting these AutoML settings and then configurations. So this is how I got all of that good stuff to work. This is not available, of course, in .NET, in addition to just doing this within Python. All right. So of course, there's a lot of benefits with this. You can actually train a model very quickly, come up with some really good results, automate the exploration processes, use resources much more efficiently, control your budget. And I did a whole bunch of tests in 30 minutes. So you can get a lot done in a very little bit of time. You can apply it to different models and domains. You can pick your training framework that you want, and you can do look at all of your visualizations and take a look at how everything turned out and why that particular one won versus some of the other ones, looking at the different results for all of them. And again, I've got over 25 different models that I ran through within 30 minutes. So I got a lot of abilities that I have with the tool to find algorithms that will be appropriate in this particular solution very quickly, and then writing code to deploy this is it's not terribly tricky at all. So once I've got my model created, what I can do is then I register. I can once I've gotten done, I can save the model. I can save input and output tensors, register the model, convert it, and create a Docker image, and then use that for deploying. So again, I have a number of Azure Compute instances that I can use, run a notebook, and that notebook will then display the URL and port that the service is running on. So this is for my deployed model. And then I can use that and put that call into any calling code where I want the machine learning model to be activated. So generally speaking, you use the SDK to get the connection information, you determine the type of request, and then you can create a web service to call the model going forward. Because it generally, when you're deploying an Azure machine learning model, it creates a REST API, and you can send data to that API and receive the prediction returned by the model. And you create the web service when you deploy to the Azure Container Instance, Azure Kubernetes, or field programmable gateways if you want to do it that way. And you can create images from these registered models and storing files. And that URI can access the web service by using the machine learning SDK as well. So again, this isn't limited to Azure Machine Learning Studio. I can do it in Synapse, and it is now using, it doesn't have to use Spark clusters, although it generally will be. And you can even use Databricks clusters if you wanted to use that as well. Some people like to do that because of the optimization that Databricks includes for Spark. So you've got a number of ways of improving the performance of your model when you have implemented it. And you can use it in a number of different pipelines. You can call it from web apps. There's a number of different ways once you've got the model created that you can use it. All right. So in closing, we took a look at what Azure ML does. We looked at how you can write your own code. We looked at AutoML, and we looked at testing, and we talked about how to deploy. And with that, are there any questions? Not seeing any. Not seeing any, but I encourage you to take a look at the doc for Azure ML, see what you can do with it. It does include a lot of things that are relatively simple to do. There's some great examples as well of how you can implement the API in your code. Like I said, I showed you in Python, but of course you can do this in .NET as well. So Sam, have you ever messed with this before?
Not with Azure ML, but I have played around with ML.NET, and that was very interesting. By the way, we do have a question in chat. Peter is asking, can AutoML handle varying number of features automatically, or need to process the data first?
So you will need to process the data first, because this isn't unique to Azure ML. But when you are creating a machine learning model, it's expecting a very specifically defined list of features. So I don't care if you're using Azure ML or not, they need to be predefined and tested so that it knows what to do with them. So it's not specific to, it's all machine learning, not just the stuff in AutoML. But yes, the features have to be defined prior to calling it.
Peter, does that answer your question? All right, very good. Anyone else have any questions or comments? Okay, looks like we're all set. Thank you very much, Ginger. That was a great presentation.
Thank you. Thank you for having me.